You're standing on a cliff, staring into an endless abyss of stars, and suddenly a flicker of light from 13.5 billion years ago whispers a secret that could unravel everything we know about the universe. That's not science fiction, it's happening right now. The James Webb Space Telescope, humanity's most powerful eye into the cosmos, has spotted a galaxy so ancient, so bizarre, it's forcing scientists to question the very rules of reality. This galaxy, called MOMZ14, isn't just a dot in the sky, it's a cosmic bombshell. Why? Because it's too bright, too complex, and too early to exist by our current understanding. And here's the kicker. Some researchers think this discovery hints we might be living inside a black hole. Yes, you heard that right. Buckle up, because today we're diving into a story that blends cutting-edge science, mind-bending theories, and a question that keeps me up at night. What if everything we know about the universe is just the tip of the iceberg? Stay with me, this is going to be a wild ride. Let's start with the star of the show, the James Webb Space Telescope, or JWST. Launched on Christmas Day 2021, this $10 billion marvel is like a time machine. Its 6.5-meter mirror made of 18 gold-coated hexagons is 3 times larger than Hubble's. But size isn't the only game changer. JWST is tuned to infrared light, the kind of light that's stretched over billions of years as the universe expands. Think of it like tuning a radio to catch a faint signal from the dawn of time. This makes JWST perfect for spotting the oldest, most distant galaxies whose light has been traveling since the universe was a cosmic toddler. Before JWST, the Hubble Space Telescope was our champion. In 2015, Hubble found GNZ11, a galaxy 13.4 billion light-years away with a redshift of 11.1. Redshift, by the way, is a measure of how much a galaxy's light has stretched due to the universe's expansion. The higher the redshift, the farther back in time we're looking. GNZ11 was a record breaker, but Hubble was pushing its limits. Enter JWST in 22, and the records started tumbling. One of its first discoveries was Jade's JWST, a galaxy with a redshift of 14.32, dating back to when the universe was just 290 million years old. But then came MOMZ14 with a redshift of 1444, pushing the clock back even further to about 280 million years after the Big Bang. That's less than 2% of the universe's current age of 13.8 billion years. Now I know what you're thinking. Numbers, numbers, numbers. Why does this matter? Because MOMZ14 isn't just far away. It's weird. It's rewriting the rulebook of how galaxies form, and it's raising questions that make even the most seasoned astronomers scratch their heads. Let's break down what makes this galaxy so special and why it's turning cosmology upside down. MOMZ14 is tiny, about 500 light-years across compared to our Milky Way's 100,000 light-years. If the Milky Way is a sprawling metropolis, MOMZ14 is a small village. But don't let its size fool you. This village is lit up like a supernova. MOMZ14 is blazing with newborn stars, forming them at a breakneck pace. Normally, galaxies this early in the universe are dim, sluggish, and hard to spot. They're supposed to be babies just starting to crawl. MOMZ14, it's sprinting. Here's where it gets stranger. When astronomers used JWST's spectrograph to analyze MOMZ14's light, they found it's packed with nitrogen, way more than expected. In the early universe, galaxies should be simple, made mostly of hydrogen and helium, the basic building blocks from the Big Bang. Nitrogen, though, comes from stars that live, die, and explode, enriching the cosmos with heavier elements. For MOMZ14 to be so nitrogen-rich, multiple generations of stars must have already lived and died. That's like finding a fully furnished house in a neighborhood that's barely been built. And there's more. Most galaxies with intense star formation have a supermassive black hole at their center, acting like a cosmic conductor regulating star birth and shaping the galaxy's growth. MOMZ14, no black hole. It's like a band playing a perfect symphony without a conductor. This absence challenges everything we thought we knew about galaxy evolution. So what's going on? My take, MOMZ14 is a clue that the early universe was a far busier place than we imagined. Our models say galaxies should take time to grow like a tree sprouting from a seed. But MOMZ14 suggests some galaxies hit the ground running, forming stars and chemicals at a pace that defies logic. It's as if the universe was in a rush to create, and we're only now catching up to its ambition. MOMZ14 isn't alone. JWST has found dozens of similar galaxies nicknamed little red dots for their infrared glow. These galaxies are popping up more often than we expected, suggesting the early universe was teeming with activity. Our current models of galaxy formation are like a recipe that's missing half the ingredients. They predict galaxies should be rare, slow to form, and chemically basic. MOMZ14 and its cousins are the opposite: common, fast, and complex. This mismatch isn't a failure, it's an opportunity. Science thrives on surprises. When I was in college, my physics professor used to say, "The universe loves to keep us humble." MOMZ14 is a humbling moment. It's telling us we've underestimated the universe's creativity. Maybe galaxy formation wasn't a slow, orderly process, but a chaotic burst of star birth. Maybe the conditions after the Big Bang were more fertile than we thought, like a cosmic springtime where stars bloomed everywhere. Looking ahead, the Nancy Grace Roman Space Telescope, set to launch in 2027, will scan even larger swaths of the sky. If JWST is a sniper rifle, Roman is a wide-angle lens. Together, they could uncover thousands of galaxies like MOMZ14, each a snapshot of the universe's wild youth. My prediction: we're on the cusp of a revolution in cosmology, one that will redefine how we see the universe's first chapters. Now let's dive into the wildest part of this story. Some scientists looking at JWST's data have proposed a jaw-dropping idea. Our universe might be inside a black hole. This isn't sci-fi, it's a serious hypothesis called Schwarzschild cosmology. Here's the gist: a black hole forms when matter collapses under gravity, creating an event horizon, a point of no return. Inside that horizon, physics gets weird. Some theories suggest that the interior of a black hole could be a new universe with its own space-time and laws. Think about the Big Bang. We picture it as an explosion from a single point, a singularity. But what if that singularity was the core of a black hole in a larger parent universe? In this scenario, the Big Bang wasn't a beginning but a transition, a moment when matter collapsed in one universe, spawning ours inside a black hole. This could explain why our universe's constants, like the strength of gravity, seem perfectly tuned for life. Black holes that create stable universes might survive longer, like evolutionary winners. There's more evidence. JWST data shows many galaxies rotating in the same direction, which is odd. In a random universe, galaxy spins should be split 50-50, like flipping a coin. This alignment, called cosmic anisotropy, challenges the idea that the universe is uniform. It's as if the universe has a preferred axis, like a spinning top. Some physicists think this could be a fingerprint of our universe forming inside a rotating black hole. Another clue: black holes have massive entropy, a measure of disorder. Our universe's entropy is also huge, matching what you'd expect inside a black hole. And in theories like Einstein-Cartan relativity, a property called torsion space-time twisting due to particle spin, might prevent singularities, triggering a big bounce where a collapsing black hole rebounds into a new universe. That bounce could be what we call the Big Bang. I'll be honest, this idea blows my mind. It suggests our universe is one of many nested like cosmic Russian dolls. Every black hole in our sky could be a doorway to another universe. It's humbling, exhilarating, and a little terrifying. But it's not the only explanation. Let's explore the alternatives. Before we get carried away, let's ground ourselves. The universe inside a black hole theory is speculative. It's a hypothesis, not a fact. There could be simpler explanations for MOMZ14 in the galaxy rotation mystery. For example, our measurements of the universe's expansion or the Milky Way's rotation speed might be off. In 2020, astronomers found discrepancies in the Hubble constant, the rate of cosmic expansion, suggesting our rulers might need recalibrating. If we've misjudged distances or speeds, MOMZ14's oddities might be less shocking. Another possibility: unknown physics. The early universe was a cauldron of extreme conditions. Maybe new particles or forces accelerated star formation, making galaxies like MOMZ14 more common. Or perhaps our simulations of galaxy formation are too conservative, underestimating how quickly stars could ignite. Here's my take. We need to stay open-minded but skeptical. Science isn't about latching onto the coolest theory, it's about testing ideas against evidence. The black hole cosmology idea is tantalizing, but it's a long way from being proven. What excites me is that discoveries like MOMZ14 are pushing us to ask bigger questions. They're reminding us that the universe is a puzzle and we're still missing pieces. So what's the lesson here for me? MOMZ14 is more than a galaxy, it's a symbol of curiosity. It reminds us that the universe is full of surprises and our job is to keep exploring even when the answers challenge everything we believe. Whether we're inside a black hole or not, the quest to understand our place in the cosmos is what drives us forward. Think about Sarah, the astrophysicist, gazing at the stars as a kid, or Aisha, the student imagining nested universes. Their stories show that curiosity isn't just for scientists, it's for all of us. So next time you look at the night sky, ask yourself, what secrets are out there waiting to be uncovered, and how will they change the way we see ourselves? I want to hear from you. Do you think we're inside a black hole? Or is there another explanation for MOMZ14's mysteries? Drop your thoughts in the comments, and let's keep this cosmic conversation going. If you love this journey, hit that subscribe button and ring the bell. We've got more universe-shaking stories coming your way. Until next time, keep looking up.